Today we're going to be talking about the fundamental theorem of calculus, part 2. Part 1 is basically when you just integrate and plug in your limits. Part 2 is when you take the derivative of that, what do you get? So let's take a look. Here's the fundamental theorem, part 1. And again, it just says that when you integrate a function on the interval a to b, you basically just take the antiderivative of little f, which will give you big F, you plug in b, and then you subtract the antiderivative when you plug in a. We've been doing this for a while now. Fundamental theorem part 1 is easy to understand. It's, as we've said before, it's basically, and I'll write this down, the area under the curve. Okay, so what can we conclude from that? Therefore, if this is true, then we can replace a and b with some functions, right? Call b h of x and replace a with g of x, two functions. So the fundamental theorem part 2 has to do with the fact that, first of all, we can replace these limits with functions. And notice that this is just an x value. So if you were to plug in, say, 3, h of 3, whatever that function is still going to give you a number back, right? And so basically, after you plug these x values in, you're still going to get numbers back for g and h since they're functions, and therefore you're still going to get just the area under the curve. In other words, this part 2 is, or this second statement is just a consequence of this statement up here from part 1. Let's take it a step further. What would happen if we plugged in these function values once we integrated and then took the derivative again without plugging in a particular x value? In other words, what if we left these as, for example, let's say h of x is x squared minus 1 and g of x is the square root of x? What would happen if we integrated this, plugged those functions in, and then took the derivative after that? Well, first of all, it would look like this, right? It would be d over dx of f of h minus f of g. What we're working on is a proof to show why the fundamental theorem part 2 works. Okay, next part of the proof is basically, notice that d dx of f of h is chain rule, because h of x is inside of the antiderivative function. What we would first do is take the derivative of the outside, which would be big F prime. Remember, big F is the antiderivative. We would take big F prime of h and then multiply by what's inside the derivative. So this is basically a chain rule with 2 steps. Outside function is big F, inside function is h. So once we take the derivative of big F of h, then we multiply by h prime. In case you might need to go back and review that lesson on the chain rule. That's a simple consequence of it. And then we would do the same thing right here. Since we're taking the derivative of big F of g, we would take big F prime first, and then multiply by the derivative of what's inside, which is g prime. Okay? So, as a conclusion, since the antiderivative of little f is big F, then we can conclude that big F prime gives you little f back. And that is the fundamental theorem in a nutshell. If you take the antiderivative of something and then take the derivative again, you get the same function back. Now, however, what we're noticing though is when you make your limits functions, okay, you're using the fundamental theorem part 1, but you're using the chain rule to understand that you have to multiply by the derivative of these functions you plugged into the antiderivative. So, what that basically means is these big F primes are now going to be just replaced with little f, and we're going to have f of h times, or little f of h times h prime, and then little f of g times g prime. Okay, so this is what we get as a conclusion to the fundamental theorem part 2. And the consequences are really easy. Okay, explaining it's probably a little bit more thorough and involved. But if you make your limits functions for the top and bottom of an integral, and let's be clear here, we're talking about little f, then instead of having to integrate and then take the derivative again, we know that from the previous slide, we showed that big F prime is just the same thing as little f. So we're just going to replace these with little f as a consequence of fundamental theorem part 1. And this will be our conclusion. And the conclusion is quite simple. And I will explain this, and then we'll get on to an example. So basically, if your limits are functions, all you have to do is plug those functions into the original little f, whatever that is. Plug those limits that are functions into little f, and then multiply by the derivatives of whatever they are, and then don't forget your subtraction sign. That's the fundamental theorem part 2 in a nutshell. Let's read this together. What this means for you is that you can simply plug in the upper and lower limits of the integrand, then multiply by the derivatives, okay? So you might be a little bit confused right now, but I promise you once we do these examples, the steps are going to be very clear and easy, actually. This is a lot easier than linear motion. The fundamental theorem part 2 eliminates the need to even take the integral, only take the derivative again. That would be unnecessarily redundant. In fact, before I finish this video, let's just do an example real quick. For those of you that are a little confused, we're just going to use some simple functions for our limits. Let's make the bottom limit 2x and the top limit x. We'll do x to the 4th. Okay, and then we're going to make our function. Let's make the function 5x cubed. Okay. So you notice that I've put in functions into the upper and lower limits of this function, which is going to be our little f, and I guess I can't forget my dx, even though it doesn't really matter. So all you have to do, basically, first of all, we're going to plug in this upper limit into our function. So that's going to give us 5 times x to the 4th cubed. So again, notice I just plugged in x to the 4th in for x here. Okay, and the next step is really easy. We just multiply by the derivative of the function we plugged in. And derivative of x to the 4th is 4x cubed. Okay, then we're going to put our subtraction sign. Move to the next line. We're going to plug in our lower limit into 5x cubed. Let's use purple for that. So minus 5, and we're plugging in 2x for x. Okay, and then we're just going to multiply by the derivative of what we just plugged in, and the derivative of 2x is 2, and that's it. And then from there, you would just simplify this, and that's the fundamental theorem part 2. So without further ado, let me end this video. In the next video, we will do an example officially and simplify it. If you have any other questions about the fundamental theorem part 2, let me know.